Okay. All right. So I'm Dave Crossland, and I'm the lead programs and operations manager for the Google Fonts team. And my role is focused on font development. And so this is a Google Fonts About page where you can learn more about Google Fonts. And to recap my background a little bit, I did interaction design as my undergraduate studies in London. And in that period, I attended many events about typography at the St. Bride Library. And at the St. Bride Library, it's one of the most significant collections of typography and historical printed reference in the world. And it really, my experiences there really got me hooked on typography. And yeah, this image from the British Library, is sort of a upside down globe from, a long time ago. And I love this image because it, it shows how, things have been global for typography, since when it was started. And this also kind of shows, a kind of skewed projection of the world when you see it, the kind of way we expect to see it even. And indeed, often the way we see the world is sort of, skewed. Here's a more accurate projection, where you can see Europe and Greenland are the right size. And so, typography has been kind of, European centric for a long time.
David,
and
sorry to
I learned it.
interrupt,
Please.
but I think your slides haven't advanced.
Oh no. Oh no. I'll zoom. Is that working now?
No, we see the map.
Okay. All right. Okay, great. Well, here we go. So yeah, that was St. Bride's, that was Ravensbourne. Here's the map upside down as it was drawn. Here it is inverted. Here's a more accurate projection. So yeah, I got really into typography because it combines these areas of visual culture, language, technology, business, and history. And something that really appealed to me is that it's ubiquitous. So yeah, I went to the University of Reading to do a postgraduate study in typeface design, and my dissertation was about the free font movement. I designed the typeface Cantarell, which, as mentioned, is used on the GNOME desktop. And so, yeah, I'm excited to talk with you today about variable fonts. So variable fonts, here's an example of the Skier typeface by famous type designer Matthew Carter in 1994. And this is a little bit of a kind of back to the future technology. So Monotype have a great blog from a few years back. They had this great image from the press in the 90s of Bill Gates arguing with the John Moore, founder of Adobe, and there was this kind of period where different font formats were coming out, different platforms, fonts didn't work everywhere, and so fast forward, 25 years, and there was this announcement at the ATypI typography conference in 2016 that this variable fonts technology was coming back, and you've got Google, Microsoft, Apple, Adobe reps on the stage there, and the big difference from 25 years ago is that it's now this ubiquitous technology. This isn't just a technology, in search of a problem. This does bring real benefits to users, like techies. And the three kinds of benefits that I see are, that we can to compress, to express, and to finesse. And so the compression aspect, here's Google Fonts, and you can see in a family like Hepta Slab, then we have lots of styles. And on the Google Fonts page, you can see up here there's a little filter to show only variable fonts. And so if you do that, you see these families with lots of styles. And traditionally, this would be lots of different font files. With the Roboto, for example, you have this range of styles of weight and width. And as a variable font, you can kind of imagine the corners of those different weights and widths and kind of fill them in. And the file size equivalent of that is, that you get the equivalent of 4 files, but you get all of these styles for the same file size. So the more axes, the more kinds of styles in the font, the smaller the cumulative file size. So for expression, this can be quite exciting because now you can pick exactly the weight that you want, within the range that's provided. And traditionally, you could maybe see a weight like this, and with variable fonts, you can get even more extreme kinds of styles and be expressive in what you choose. And so I've been working for the last few years with David Burlow at the Font Bureau company. He's worked on this technology 25 years ago with Apple, and he worked on two typefaces. The first is Decovar, which sort of really tries to show off how expressive variable fonts can be. Because within this typeface, there are dozens of kind of common styles, it's something that you can kind of pick and mix the different variations. And so potentially there's dozens or hundreds of styles. And on the Axis Praxis website is a great kind of playground for variable fonts, and you can see you've got all of these different axes of variation to play with. And that's possible because David is sort of thinking about things native to the format. So you have the Adobe multiple master model here, where we have these corners that are filled in. But the Apple GX model was a bit different. It starts from the center, and then you have these interpolation masters or matrices, which you extrapolate along, and those can be combined. And so the overall range of weight and width shown here in both examples is the same, but the way it's constructed is different. And that's really what Decovar is leveraging to provide that range of different styles. It's the blending or the combining of the axes. And so to think about it in mathematical terms, these are vectors, and they're just being sort of added and subtracted from each other. And so that brings us to the third benefit, to finesse typography. And so even with a variable font with kind of only one axis of weight, you can see here, we have this Arabic kind of headline. And if we increase the weight, then the letters get wider too, and then that breaks the headline into two lines. If we were picking a kind of more medium weight, if we were to fine tune that weight, we could find, that by adjusting the apparent width through the weight axis, we could do some headline fitting. And so we could kind of finesse the headline so it was a medium weight, but it was just the right medium weight to fit the headline onto one line. And so perhaps the sort of most interesting axis for optical size for finessing typography is optical size. And so the other typeface that David Burlow developed a few years ago is Amstervah. And this is really pushing the limits of how it can vary for fine text typography. So you can see here there's designs for small sizes and large sizes. Here, those designs are shown, as kind of scaled up or down to all be the same size normalized. And you can start to see the differences in the letter forms, which are size-specific designs. And so here again is, sort of a range of the sizes all scaled to the same size. This animation then starts to show how these work, together in practice. You can see the way the letter forms are changing, both, scaled, fixed to the same size, so you can see what's happening, and then, the letter forms are changing as well as the actual size is changing, so you can see the effect as it's to be experienced. So where could you obtain some of these optical size designs? Well, if you go to fonts.google.com/variable-fonts, which you can kind of find through our about page, you can see you can filter for the different axes available. You can see that we have some font families available. And so one Literata, I'll do a quick highlight on. You can also see this from the Type Foundry's website, Type Together. So this type family has quite good glyph set. It's got Latin, Greek, and Cyrillic, and it's been designed for reading ebooks on screens, and it has a broad range of weights and a range of optical sizes. And on the Foundry's webpage, they have a kind of demo site where you can kind of experience in different formats the typeface. So you can see, in dark mode, you could adjust the weight slightly to optimize it. And you can see how the optical size can be adjusted for different formats. And then at the end of the demo, they have this interactive playground where you can sort of see there's this, sort of different sizes, different weights, and how they work. In working with David Bellow, he's developed this app typetools.typenetwork.com, which is a free Libre open source web app for previewing and playing with variable fonts. And so one of the important ways to use optical size fonts is that you can see in his app, they have this little mirror size changes toggle down here, where the optical size is related to the font size and is kind of mirrored. So as you change your size, the optical size is changing automatically. And this is actually built in to CSS. There's a CSS property, font optical sizing auto, which is on by default, and that will automatically set the optical size. And this isn't a totally novel idea. I found this great email, discussing this idea of auto selecting optical sizes for a font from 2013. If you're using, variable fonts in a tech engine, I think it's well worth investigating this because it's a very powerful feature. So I want to now kind of change tacks a little bit and talk a little bit about some of the theory behind why optical size or size-specific design styles are designed. Because as a user, you have the ability to accept the automatic size selections, but you could also override them and set them, more appropriately for your document. And so the first idea I had to show you is this, idea about human perception. That the way that we read type is to do with our physiology, our neurology, and there are certain limits to this. So here's an optical illusion that's kind of fun, where it says, there are these 12 black dots, and if you look around this image, you kind of get the sense that the dot you saw disappeared. And in fact, there are no dots. It's an optical illusion where the dots are being sort of hallucinated because of the weird interplay of white and black shapes. In this example, this is actually spinning. It's not just your mind playing tricks on you. The tricks your mind are playing are those white kind of faint beams radiating out from the center that don't really exist. This example is pretty freaky. If you just stare at the middle of the page and just focus your eyes in the very middle of the page and relax, you should get the sensation that all of the sort of chaotic lines are kind of fading into a regular grid. It's very strange. So another example of how our visual perception can be played with, this is actually a black and white image, but then it has these colored lines cut through it that kind of make us hallucinate it as a full color image, which you can see if we just cut out most of the image, you can see it's a grayscale image with bands of color. And then similarly, turning back towards type and black and white, you see these two dots. The left one appears much lighter than the one on the right, but indeed they are the same gray. It's the context around them that's changing your perception. This example, goes back to movement. It is a still image, but if you look around it, especially like if you looked from one corner to another, you get this kind of shimmering effect that's a little bit kind of vertigo for me. And this indeed has been used in type design for kind of psychedelic lettering. So the point of showing you these examples is to, sort of just remind you that you can't always believe, what you see. And some of these optical effects or illusions are very relevant to type design, everyday, regular typeface design and typography. So here we can see, horizontal bars of the same length that look different lengths based on the context around them. Dots that look different sizes based on the context around them. Straight lines that look crooked. Straight lines that kind of bend and warp. Yeah, lots of strange things can happen when looking at black and white shapes. And so that's a big concept for optical size design, that we can adjust the typeface to mitigate these kinds of effects as they change at different sizes. And then that raises the question about what is size. And so often viewing distance isn't fixed. Obviously, when you look at the moon, it's smaller than your finger. That's because of the difference in distance between those two things. And so when you're dealing with type and optical size, this is also an important aspect of the nature of size to be aware of, that your reading distance is going to change things. Now, this illustration is sort of where we really get into the meat of it. So you see here, this is a spatial frequency graph, and you get a sense that there's a kind of hump in the middle where the black and white bars extend up before kind of disappearing and becoming totally gray. And different people have a different kind of shape of that hump based on their own individual, biology. And if you move further or closer to the screen, you'll also kind of see that kind of hump shifting. And so in the way that this relates to type design is that these optical size adjustments in different letter forms are trying to optimize for that spatial frequency kind of tune, that like the way that your visual perception system is going to enjoy a certain spatial frequency, which is like that kind of hump that you see at the bottom here, is kind of what's happening, that we're trying to key into that as the type gets smaller or effectively further away from you. And the sort of state of the art of this, over 120 years hasn't really changed. So above we have an example from Century Gothic from American type founders from 1900, and then here we have a new typeface called Roboto Flex. And so David Berlow, the lead type designer on these projects, has this idea that these size-specific designs, it's not about designing for elegance at large sizes. It's also a legibility optimization as well as at small sizes. So I want to talk about those two things, large and small sizes. So briefly, large sizes, company logos we've often seen become, kind of nice, thick, almost monolinear sans serif designs. Lots of companies have done this kind of, rebranding in the last few years, both in the technology sector and in other marketplaces. And so part of the reason I think that that's happening, David Berlow's proposed that's happening, is because they need those brand logo types to be resilient across all kinds of environments. And so optical size variation, you can see here, at the smaller sizes, this company logo becomes less legible, less easy to read. And by moving to a sans serif design, then without any variation, it's more resilient at that small size. But with variation, it's possible to have something which is changing subtly and retaining that resilience. So here you can see, sort of the toggling between them, all those changes happening. So then for smaller sizes, how can this kind of work for improving readability? Well, readability, reading fluency is about comprehension, retention, and speed. And Dr. Bonnie Shaver-Troop introduced me to this idea that through type design and typography, we can actually affect the user's speed of reading and thereby improve their comprehension and retention. And so there's two ideas here. One is the kind of stem rhythm. In a word like minimum, then we have this fence post effect with the letter form stems, the white spaces between them. And then when we're reading along a line, our eyes are saccading. They're sort of bouncing along the letter like a pipette, kind of picking up fragments of visual material and stitching it together into our hallucinated perception of the world around us and the page, the line, the text. And so you can see that because of that saccade process, you can rearrange the letters inside a word and actually read quite reasonably. A little bit slowed down, but I can kind of comfortably read this. Similarly, you can also kind of flip a paragraph around, and if you try to read these second, third, fourth paragraphs, it's surprising for me how fluently I could read these totally strange looking paragraphs. So this idea that we could use typography to improve our reading, I think is really powerful. And there's this project Lexend that Bonnie had been driving the last few years, which is trying to allow users to adjust their typeface to improve their reading. And variable fonts is an ideal technology for this because, as you can see on this slider down here, you can adjust the typeface, making it wider, both in terms of the interletter spacing, the space between the letters, and the inside transparency, the kind of counterform spaces inside the letters. And so what you might find is, as a very fluent reader, the regular sort of hyperextension, they call it, the combination of interletter space and inner space is very comfortable and you can read very well. But more beginner readers may find that by slowing down the speed of their saccades by making the distance longer, then they're able to kind of sync up their neurological and physical reading processes and improve their reading. So for product and page design, how can these things be worked together? Well, with the Roboto Flex font I mentioned, I want to kind of focus on some of the details here. So this is the classic Roboto used at a range of different typography styles and sizes, and you kind of can get a sense that it's a little bit uneven. So with Roboto Flex, we have a fluid optical size range of styles, and this provides a much more even color across those different sizes. Here you can see kind of two up the comparison, and you can see it's a smooth continuum where the style is kind of regularized. And here's the 32-point design that's kind of misapplied to all those sizes. So you can see it looks good in the headlines and it's less comfortable in the smaller sizes. Likewise, if we take the 14-point design, that's going to improve that paragraph, but at the top, it's becoming a lot longer, even seems to be bolder. And so what we can do to kind of finesse this before variable fonts is to use the lightweight for that large size, which makes things a little bit more even. But with a variable font, with the automatic optical sizing applied, this is making the color more even. It's making things more comfortable read in the body text. It's improving the speed and comfort of reading the headlines because they're a little narrower, as well as lighter, and it's better typography. So again, here's that kind of comparison of the smoothness. And now this is just for regular. So how does this relate to other styles? Well, we originally, with Roboto, there was this very limited range of styles published. The condensed styles didn't have all of the weights, and you can see subtle, but you can see the Roboto condensed bold is slightly heavier than the regular bold. Not as much as the black weight, but slightly. So what is happening there? Well, the reason is that we have this typical font family, where all the styles from regular and Italica evened out, you get a complete set. And at this size, all of them seem to be working well. But when you start to scale them down, then the styles on the edges start to break down. They start moving out of that spatial frequency, sweet spot. And it's really those core styles which are more useful. So a way of thinking about this is a kind of upside down pyramid. And type designer DJR, David Jonathan Ross, has published this Roslindale family using an interesting business model. It's called the Font of the Month Club, where he releases one font style every month. And he's released this family, over months, style by style. And has made this great illustration. He says, what I'm sending you today, he's just sending, these styles. And there are these other sizes designed for smaller size usage with a much more limited range of weights and indeed, different widths. And so they form a kind of pyramid system where you have this greater range of weight and width, where you have more room for it. And at smaller sizes, there's just less room for the strokes to get thicker, the counterforms to get thinner. And so here's an animation of kind of what that looks like for Roboto Flex. So you can see as the size is increasing, there are these adjustments to the proportions. The X height is going down, the stroke weight is going down. So now let's see through the range of weights that with more room, we can really increase the weight. So the black weight gets really heavy. The width can get a lot wider, and the condensed style can get more condensed. And that can become quite extreme when we reduce the weight as well. So the most extreme minimum width, minimum weight design is extreme. So this obviously, allows us to have a much greater range of kind of expressive choices. But going to the text typography again, this typeface has a lot of personalities. But if we choose one of those personalities, we can still get that smooth range of typography at different sizes, even though we're no longer in the kind of regular default style. And so the way that we can do that is because of what the Font Bureau call the parametric axes system. And to really understand this, you have to look a little bit at how they design type. So these axes, there's kind of two big sets. There's the transparent axes, which are changing the spaces inside and around the glyph. And those are broken out into X and Y dimensions. And then there's the opacity axes, which are changing the stroke weights, again, split out in terms of X and Y direction. And so those four axes can be combined in various ways to create the weight width optical size axes. So you can sort of see here, we have these animations showing this step by step. So optical size is, these variations are developed by combining or blending the XTRA, X transparent, the spaces within the letters in the X dimension, the XOPQ, the stroke widths in the X dimension, and the YOPQ, the stroke widths in the Y dimension, plus changes to ascenders, descenders, and overall lowercase height. So let's kind of step through with that. In the example of Amstervah, we start with the default design, and then when we're designing the optical size 8-point design, then these are the steps we would take. We would adjust the X dimension OPQ, opaque stroke shapes. Then we would adjust the X dimension transparent shapes. And then we would adjust the lowercase, making it larger by increasing the transparency, the spaces inside the lowercase letters. And then we would increase the stroke weight also in the Y dimension, reducing the sort of stroke contrast. And that produces this optical size 8-point design. Similarly, for going to our largest 144-point design, then we would want to start with the Y dimensions stroke widths and really make those very high contrast. Then we would take the X height down, and we would further adjust, the stroke weight a little thinner, and then we would, make this big adjustment to the counterforms inside the letters, the sort of the X dimension transparency. And so with those interpolation masters, we would then get this complete range of sizes, which I showed earlier. So this is this idea, that the Amstervah, you have this fluid range of optical sizes, but as a user, you also have access to these underlying axes. So you can really fine tune the text typography. So if you, want things to be customized, not just the defaults, you can do so. So here's a practical example, diving deeper into the X transparency, the Y transparency, the height of the kind of counterforms, the spaces inside the letters. So you can see the Y TRA axis overall is adjusting both the uppercase and lowercase heights, the ascenders and the descenders. So then there are this kind of third level of axes where you can individually address the height of the lowercase or the height of the uppercase. So a practical application of this very fine control over specific aspects of the typeface would be, when you're doing interscript matching. So here we can see, Roboto is paired with the Noto Sans Thai typeface, and you can see that, for good typography, we want the baseline aligned, but also we can adjust the design of Roboto to be a little bit taller in its ascenders to kind of nicely align and harmonize with the Thai. Now I want to struggle a bit with the Zoom app. I want to break out and show this current example of work David Burlow's leading today. It's kind of cutting edge stuff in collaboration with the developer Larsa Fista. So I think if I click this link, can you see this now? Is it working?
Yes.
Okay, great. So yeah, so you can see as I loaded this, it loaded the Wikipedia page on typography, and then it's sort of line by line adjusted the typography. And so what it's doing here is a kind of sophisticated hyphenation and justification algorithm, which is using this X transparency axis. So it's not just the width axis where there are other changes blended in. It's just purely using this X transparency axis to optimize the page. And up here on the top right, I have this little control. So I can say, some different viewports. And then I can control here, and I can pause it. And so you can see here, this is using the XTRA axis, and in addition, adjusting CSS letter spacing and word spacing properties. Yeah, if I reset it and then rerun it, I think you can see again how it's improving the line justification. Okay, if I go back to the slide. Oh, no. Oh boy. No. Oh dear. What a muddle. Hang on a sec. Let me restart the screen sharing. All right. Okay, share screen, share the window, share the window. All right. Okay, so where could you learn more about this? Well, David Burlow has been working on a kind of brochure to go through these, these topics of typography and these ideas like, interscript matching or better hyphenation justification. And so that's at the variablefonts.typenetwork.com site. I think there's a big opportunity to, apply this to like the microtype, package. And to use variable fonts to really finesse text typography in the tech typesetting engines and your documents. All right, thank you very much. Is that, yeah, here we go. So I think we've got about 10 minutes for questions and discussions. Let me look at the chat here.
Thank you, David. And if you have questions, just join live and raise your hand or just come in.
If I may, Paolo, I have a question and a short comment. My comment is that for us techies, it's very nice to know that at least LoaTech now supports variable fonts and different axes, and I think that and you can use it using current font spec with raw feature, I think, which is absolutely great. And my question is, how much more effort does it require from font designer to add axes, and how much more work is this to just not to design a font, but design a font which would have axes and it would not look absolutely bad in all the combinations?
That's a great question. Well, yeah. So I think definitely I had pointed out that the LuaTech developers have been working on variable font support, thinking about optical size for nearly a decade. Plus, in fact, part of the heritage of this is in Donald Knuth's Metafont. Computer Modern has optical size variation. The original text system does this kind of optical size variation. And that is like the most difficult approach, right? Asking type designers to do real meta font programming, basically, it's extremely high bar. And the Euler project, in the AMS Euler project, they get famous project, they gave up, right? They were at Stanford, they couldn't do it, right? They went back to using Metafont to draw outlines like a PostScript font system. So yeah, this approach, of variable fonts where you still draw the outlines and then you interpolate them, gives you some of the power of the full Metafont, Computer Modern fonts, but it strikes this balance where it lowers the bar to the execution of the typeface in font technology. And while the GX model had kind of died out for 25 years and then was kind of reborn with Bedad, who was here. He's really one of the key people at driving this in the last 5-6 years, along with Adam Twardok, who another techie. I think he's the president of the Polish techies group, Gust, at the moment. And so Bedad and Adam, I think are really kind of key initiators of this effort to make variable font technology so ubiquitous. And so what happened when GX was down was that Adobe Multiple Masters was kind of up in the 90s. And at the beginning of my talk, I talked a little about my educational background. I studied at a London design college, and it was actually at that time when I was just beginning my undergraduate studies that Adobe took away the multiple master features from their applications, and I was kind of pissed. It's one of the things that kind of radicalized me about free software and learning about the tech software for typography, because it was free Libra software where no one was going to take my features away. And so that technology went into font editors, particularly the Font Lab proprietary font editor, which Adam is employed at as a product manager. And so type designers have been using interpolation pretty much for those 25 plus years. And so what we see is a lot of variable fonts with weight and width axes, because really they've been using weight and width axes in their type development for decades. And so in Font Lab or GlyphZap or common popular font editors that have used interpolation features for design time, they just added like an export checkbox, export GX variable fonts, and then boom, right? But the reason I'm working with David Berlow is because he was had this longer history with the GX model, which has this different kind of mathematical basis, which I showed, right? You start from the center and go out, you can blend things. And regrettably, there hasn't been a lot of innovation in type design applications to help designers design variable fonts kind of natively. And if you're kind of familiar with this like Marshall McLuhan ideas of media, then often what happens when a new medium is developed is it's used to mimic the previous technology, and then later you see kind of native expressions of the media. And so like in the beginning of radio, people would wear suits to announce the radio because they were used to public speaking, and television was like a camera in the middle of an auditorium just recording a stage play, and then you had Citizen Kane and cinematography, and it like changed it. So I really see David Berlow as that kind of Orson Welles character here, where he's designing type kind of with like the grain of the GX technology, the variable fonts technology, and this blending is built into Decovar and Amstervah. And one of the reasons he's working with me on these free Libra fonts, very surprising, that a font bureau would do this to some people, especially, a few years ago, is that by making these fonts and their source files available to everyone, we want to encourage more people to make fonts like this. And so the role that the tech community can have, the reason I want to present this to you today is because if we start to see people learning about this, thinking about it, and using it to produce better quality typography, then that's going to lead people to say, well, I can do this with Roboto, Flex, and Amstervah. Now I want to do it with, say, Literata, and there's going to be this demand for type, foundries, font developers to make fonts this way. So maybe that's, a little bit quixotic, a bit ambitious, but that's really what I would like to see happen in the world. And these parametric axes, if we just use the XTRA axis for justification, well, it's not so, crazy to take an existing type design and just add that one axis for that one benefit, and then you could improve your hyphenation justification using a built-in automatic algorithm for it, like optical size has this automatic application. And you could see that in a lot of typefaces, and it wouldn't have the wide transparency interscript, matching with Thai or Chinese or whatever, but it would just have the XTRA for the, the justification. So Roboto, Flex, and Amsterdam are kind of, kitchen sink, everything is there, the full parametric set, and it's a bit of a tour de force, and it's not necessary for everyone to do every axis. So I really hope to see, type designers, adopting these axes. And the key to that, I think, is to start to see usage. And so that's why I'm very happy to have Roboto next generation as Roboto Flex with this stuff. And we'll see what happens.
Thank you. Thanks.
David, I have a quick question.
Please.
How is the testing done on variable fonts? Like, so suppose I have I have an X to the power of E, and the E is very small, and in that particular case using a variable font, how do I know for sure that that little hole in the little E is not gonna disappear because of the size or because of some font parameter? How is the testing happening by hand on every device, on every print, every output possible, computer?
Well, I think one of the things with type and typography is that every font is kind of unique in this respect. A classic thing, right? A lot of beginner typography people would say, wait a minute, when I set the font size to 20, these two fonts look totally different, even though they have the same size. Right. And that's because what is in the font is up to the font designer, and so I think it's very difficult to make broad statements about that. I think the reason I'm passionate about free Libra open source licensing of fonts is that if you get that problem and you write to the font designer, you say I've got this problem, will you fix it? And they say no. Then you can go and find someone else who will say yes, right? And
Mhm.
to me, that's like very, very exciting. That's why I've spent my career working on this. And so with variable fonts, the technology, the technical complexity is increasing. So the rate at which you are likely to find that kind of problem that you've encountered that in their testing they didn't surface and fix already is also going up, right? The technology sophistication is up, the probability of bugs is up. And for me personally, the importance of having a free Libre license is up. And yeah, it just depends on the font. I think what I've seen in the tech community, which is I think kind of nice and sophisticated, is that when people like some proprietary font and it has some issues because it's been maybe say made for other systems than the tech systems, then they make some nice package that's on CTAN that like ameliorates some of those rough edges and like makes it work well in our systems. And so if there's one glyph that's wrong, potentially you can make your own font that's just got that one glyph, right? And it does the thing that you want it, and you can kind of overlay the two fonts in your font stack and fix it that way. I don't know. It's a very broad question, so I can't give an easy answer. And we're out of time. I'm sensitive to that. I think we have to move on to Matthias Roche's how to make a logo symbol for a font talk.
Thank you very much.
Which is sort of on that topic. Yeah.
Thank you very much.
All right.